And under polynomials, you can file this way of stuff you'll probably be never asked again, but hey, why not? Adding and subtracting now. Don't let the word polynomial scare you. What does polynomial mean?
Terms.
Poly would be many terms.
Monomials.
We've got this. Those are polynomials, generally speaking, but they have specific names. Since this is just a one-term thing, it's called a monomial. A who?
A binomial?
Well, that's where we're at right here. Look. Since this has two terms, Parker says, is there such a thing? Yes. It's a binomial. And this one here, since it has three terms, it is a trinomial. That's really as far as we go, as far as making specific names for something. If it has four terms, we don't call, well, we have quadratics. We don't call them
Quadranomial.
They don't really use that. But sometimes they talk about this. They talk about degrees of polynomials. I think we may have talked about this last year.
Yeah.
Right? And the degree of a polynomial, well, the degree of a, first of all, the degree of a monomial. Let's do that first. Monomial. It equals the sum of the exponents of the variables, which is a lot of big words that really don't mean anything hard, but I'll show you what that means here. If you have, let's say you've got 3x squared y. If you're looking for the degree of this, numbers don't count, even if they have exponents with them. You just look at the exponents of the variables, which are x and y has a 1 there. Add those together. This is a third degree monomial. If it would be 5x to the 5th yz, what would be the degree of this? 5 plus 1 plus 1, it's a 7th degree. As we move along, now, the degree of a polynomial let's say we had that trinomial up there, which was 3x squared plus 2x plus, I'm not sure, equals 9. If you're looking for the degree of a polynomial, it is this. See if you can follow this logic here. The degree of a polynomial, the degree of a poly is equal to its highest degreed term. I'll let you write that, and then, and only then, will we discuss what in the world that means. Does anybody know what that means? Evelyn, what does this mean?
So then there's the 3x squared, so then that's degree of 2, then the 2x is only 1 degree, and the 9 just is no degree. So therefore, the degrees of the poly is the 2 because it's 2.
You have to look at each term, like Evelyn said. This is a second degree term. This is a first degree. This is no degrees. The degree of the polynomial is equal to the highest degree term. So this is a second degree polynomial. For your higher term degree there is that second one. And with that, again, this is something you'll probably never run across hardly ever again, but it's in the book, so we'll do it. And then usually, you write polynomials in descending degree order. Not that it's wrong not to, but just for consistency's sake, now people say, okay, you put the term that has the highest exponents first. So really I should write this as 5x to the 5th first. I can't write there. And then the minus 2x squared, and then the 3x, just for consistency's sake. And it's all good.
Wow. Who did it come up with that? Are you ready to forge ahead?
Now, back to what we actually were supposed to talk about today, which was adding and subtracting polynomials. Under the same notes here, write down these two examples, adding / subtracting. So example number 1 and example number 2. One adding, one subtracting. Let's say you have this as a problem. Gosh, why do I have to do this? All right, there's too many things. Negative 8x cubed plus 4x squared plus x plus 1, parenthesis, plus 3x cubed minus 2x squared plus 7, parenthesis. And then for the other one, 6x squared plus 4x plus 2 minus 2x squared minus x plus 8. You got those? What's that, Parker?
Said, I don't like where this is going.
No, this is, in my mind, stupid. For the most part. For the most part. Alright, first of all, this is not multiplication, this is adding and subtracting. Just keep that in mind here. Here's what you just have to keep in mind with this. Okay, if it is a plus sign in front of a parenthesis, it really makes no difference. It really matters. You don't. If there is a plus in front of a parenthesis, you don't need the parenthesis. They don't even, they make no, they're irrelevant. In other words, this. You could take these parentheses away and just add like terms. You have an 8 minus 8x cubed here and a positive 3x cubed there. That gives you a minus 5x cubed, right? Negative 8 plus 3. You have a 4x squared here and was that a minus 2x squared there, which gives you a 2x squared. And you have a plus 7 and, oh wait, you have an x there. which you have to keep. Then I have a 7 and a 1, and I get 8. Okay? Those parentheses really don't do anything or mean anything. To which you say, well, why do we have them? And I say, I don't know, but this is where they do. If it's a negative in front of parentheses, then you have to use the distributive property with that negative. Which just means this. Looking at the first parenthesis, there's no sign in front of it, so it's a plus sign. So this parenthesis you don't even need. You could just rewrite this as 6x squared plus 4x plus 2. But this, ladies and gentlemen, is where the wheels always fall off. If there is a minus sign in front of that parenthesis, that means you have to distribute out that minus sign to everything in the parenthesis. So really it just means everything in the parenthesis changes to its opposite sign. This becomes a minus 2x squared. Minus a minus x is actually plus x. And minus a positive 8 is actually minus 8. You can get rid of all the parentheses, and then you can add like terms. 6x squared minus 2x squared is 4x squared. 4x plus x is 5x. And plus 2 plus 8 is plus 10. Really, this is not the most exciting stuff you've ever done in the world, but parentheses are not needed if there's a positive sign in front. You have to distribute out the negative if there's a negative sign in front, and then it's all water under the proverbial bridge. How about that? Do you think that's exciting? No. And rather than going to box and whisker plots for the third time, does anybody remember anything about box and whisker plots?
Your boxes and whiskers.
They are boxes and whiskers. Lower quartile, upper quartile, middle quartile.
Oh, yeah.